Example 3 follows all the same routines as the previous examples. We do have our like terms lined up, each with their own column, so we're just going to add going down, or do what the signs tell us to do going down. 15 combined with 4 x's is going to leave us with 19 x's. Positive 3y and minus 3y are going to cancel out to 0. So y is the variable that has been eliminated. 51 plus 6 makes 57. After the first step, you should always be left with a one-step equation. We undo a times 19 with a divide 19. And we find that x equals 3. Even if you can't find the second variable, you should be able to find the first variable because it's not too many steps and it could still earn you half the credit. Half the credit is a fool's game if we can get full credit though, so we're going to plug this x equals 3 back into the original equation. Instead of 15x, we're going to go 15 with a blank parenthesis plus 3y equals 51. Again, you could use the top or bottom equation. Out of habit, I usually just use the top, but it doesn't matter. You would get the same result either way. Remember, we're changing x to 3, so we're going to fill that parenthesis with a 3. Always distribute as soon as you can. 15 times 3 is 45. We've used those items up, so let's copy down what we have not used. Plus 3y equals 51. Remember, save the letters for last. I'm going to save this 3y for the last step. I want to get rid of this 45 first. If I want to take a positive 45 and send it over to the other side, it becomes a minus 45. We'll find that 3y equals 51 minus 45, which is 6. And when we undo a times 3 with a divide 3, we'll find that y equals 2. Now that we've found x and y, all that we need to do is put them into a coordinate pair. X first, then y. As I said before, each of these equations would graph as straight lines if you put them on a graph. And those two straight lines would cross at exactly one point. That one point would be 3 on the x-axis and 2 on the y-axis.